Hey, this is Coach Latham, and this is your SOL Geometry Review Part 3. We're going to start today with circles. Some of the basics that you'll need to remember is that the diameter is always twice the radius. If you're given the radius in a circle of, say, 12 centimeters, you have to remember that the diameter is going to be half of that, or 6 centimeters. The first thing that we started studying was central angles in a circle. Central angles in a circle are angles that are right in the middle of the circle. In other words, the vertex of the angle is the center of the circle. It's the exact same degree measure as the arc it cuts out on the outside of the circle. So if this is a 75-degree angle, then this is 75 degrees of arc. Here's another one. Try to work this one out on your own, but make sure you read the directions. All right, well, this one, you have a 60-degree central angle, which means that we've got 60 degrees of arc here. And if that's what we were asking for, you would be done. But it asked for the measure of arc BAC, which is this arc right here that goes around the rest of the circle. Since any circle has 360 degrees, that means that this other part over here is 300 degrees. Here's a similar question. Make sure you read it and give it your best shot. This one says that the measure of angle AOB is 100. And we want to know the measure of arc ACB, which is that one. Okay, well, if this is 100, then that's 100. And 100 from 360 leaves 260 for the degree measure of that arc. This is our first look at an inscribed angle. An inscribed angle doesn't start with its vertex in the middle of the circle. It starts on the circle. And the relationship there is that its arc is always going to be twice its measure. So this is 80 degrees of arc degrees, and then the rest of the circle would be 360 minus 80. This is the second half of that question. It asked for this arc right here, BAC, and so since this is 80, it's going to be 360 minus 80, which will give us 280 for this part. This is the one I call the Pac-Man problem. We've got a central angle here. So we know that makes this 44 degrees of arc. And since we have an inscribed angle that cuts out the same amount of arc, it's going to be half of that. So this is 22 degrees. This one is similar to the one we just did. Take a minute to see if you can figure that one out. This one is an interesting problem. It just shows the relationship between the triangle and the circle. These are all inscribed angles, so if this is 60 degrees, this is 120. If this is 62, then this one is 124. And if this one's 58, then this one is 116. They asked for arc AB here, so that's the one that's 124. See if you can figure out how many degrees PR is. Well, since this is a 90-degree angle and it's inscribed, that's going to make this 180 degrees of arc. Finding the area of the circle is basically using the area formula. It is on your formula sheet. Area equals pi r squared. So for this one, it's going to be pi 10 squared. Circumference is also on your formula sheet. It's C equals 2 pi r. And r here is 5, so it's going to be 2 pi 5. You can find the circumference of this circle. Remember to take your diameter and divide by 2 to get the radius. And you can find the area of this circle. Remember to divide the diameter by 2 to get the radius. And here are the problems that they have a couple of on the SOL. You're going to have to give me the area of this sector right here, the 95 degrees of the circle. Well, since it's 95 out of the 360 degrees in a circle, then our fraction in front of the problem is going to be 95 over 360. And we're worried about the area, so we're going to use pi r squared, which is going to be pi 3 squared. So the one that has 95 over 360 and pi 3 squared is going to be C. Oh, it's going to be D. Can't read. This one is going to be done the same way, only now we're working with the circumference, so it's going to be C equals 2 pi r, and 2 pi r for this circle is going to be 2 pi 5. Again, it's 95 out of 360, so it's going to be A. Try this one on your own. And there's our answer. And now we move into the relationship between angles formed inside of a circle when you have a couple of arcs or secants that intersect inside the circle. Now you can see that the angle that we're searching for right here opens up to 100 degrees of arc on this side and opens up to 46 degrees of arc on this side. So it's simply the average of those two. You would add 100 plus 46 and then divide by 2 and get 73. That tells you that this angle is 73, this angle is 73, and then of course you can figure these angles out as well. They got to add up to 180. Work this one out on your own. Here's your answer. Work this one out on your own. And here's your answer. Hopefully you remembered that we were not looking for this angle, we were finding this one, which meant that after we found our first answer, we had to subtract from 180. Now on this one, it's a little bit different because they intersect outside the circle. The way I remember it is that the answer is not in between these two numbers, it's outside these two numbers. So on these, you're going to subtract the arcs and divide by 2. In other words, 100 minus 30 is 70, and divided by 2 gets me an angle of 35. You can try this one on your own. And here's your answer. Remember, if this is 260 degrees of arc, then the rest of this thing is going to be 360 minus 260, which is 100, if I can write it there. So 260 minus 100 is 160, and then half of that's 80. Here's one you can try on your own. And hopefully you got the 50. Now we shift our attention to angles that are formed when chords and secants intersect inside of a circle, to the distances of parts of those segments or lines. In this one, we strictly need to remember, that we're multiplying the parts together. So on this one, in order to figure it out, it's going to be 3 times x, the two parts of that line, is equal to 5 times 4, the two parts of that one. And when we work this out, we get 6.6 on the calculator. This is one that's a little bit tricky to remember. It's always, when the intersection is outside and you've got an outside part and an inside part, it's always the outside part times the total length is equal to the outside part times the total length. So when we go to set this one up, it's going to be 5 times 5 plus 3, which is 8, equals outside part 4 times the entire length, which is 4 plus x. And then you work this out and you get 6 for an answer. You try to do this one on your own, see what you get. Try to do this one on your own, see what you get. And I'll remind you that in this top part, the outside part and the entire length are the same thing. And here's your answer. And that moves us into the equation of a circle. Now, the equation of a circle is given to you on the formula sheet of your, it's given to you on the formula sheet when you take the SOL, and it's always in the form x minus h squared plus y minus k squared equals r squared. And what that does is it really makes these numbers seem like they're opposites because we've got minuses built into the formula. In other words, if the center of the circle is at 3, 4, I'm looking for x minus 3 and y minus 4. That leads me down to these bottom two. And the number on the end is the radius squared, and we can count that off. 1, 2, 3. 3 squared is 9, so that's going to make C my answer. Figure this one out on your own. Hit pause and see what you get. And here's our answer. And here's one for you to try going backwards. I give you the equation of the circle, and you've got to find the correct picture. So looking at the equation, remember they look like they're opposite. So h is 3 and k is -1, which means the center of this circle is at 3, -1. Well, that means that it's got to be either this one or this one. These are the ones that have centers of the circle at 3, -1. It also tells us that r squared is 16, so the square root of 16 is 4. I'm looking for the one that has a radius of 4, which leads me down to this one. He is our winner, and this one is the one that goes by that equation. All right, the last thing that we need to talk about are the constructions that you will be asked about on your SOL test. And there's really only 6 questions they can ask you here. This one is asking you to figure out which one they're doing, and this is a perpendicular bisector. If I were to connect these crosshairs right here, you would see that it cuts segment AB in half with a perpendicular. So this is perpendicular bisector. This one is a perpendicular through AB through the point off the line D. So the key words here are perpendicular through a point off the line. This one is a perpendicular through a point on the line. This one, we're cutting this angle in half. So if I were to connect out through here, I have an angle bisector. You see 2 things here. So we're copying something. When we connect this, we see that we've made a copy of this angle. And finally, here we have 2 things. So we're copying something, and this is a copy of a line segment. Hopefully this has helped you to review for your SOL test. Remember to go back through all 3 videos, turn the sound down, and see if you can get all the answers. Good luck. I know you'll do well.